Good morning. Thank you very much for coming to this session about testing. It's a long talk, but we are going to, take some breaks and so on, and we are going to show you some tricks, let's say, to develop tests that are easy to write, and more important, also they are easy to read. And we are going to see from the simple one like unit tests to deployment tests. And some of the things are really focused on microservices architecture, but I would say that 80% of the slides you can reuse it, or you can reuse them even if you are using a monolith approach in your development. My name is Alex Soto. I work in Red Hat. I'm the curator of lordofthejars.com, and also my Twitter is AlexSotoB. If you have any question, any suggestion, whatever, just ping me on Twitter and I will answer you as soon as possible. Basically, I don't put here my email because, you can send me an email as well, but then it will, get a bigger on my inbox, and it will take like 2 weeks to answer your questions. So with Twitter, it's really fast.
Holy moly, people. This is a lot of pressure. Good morning, everyone. Welcome to Devoxx. Welcome to our talk. I'm Andy Gumbrecht. I'm a committer on the Apache Tommy project, also on the PMC. I'm also a dad, but if I posted my kids on here, they'd just kill me, so you're not going to see my kids on here. And the same goes for me. Anytime on Twitter, just ping me on Twitter. We're both very public guys, and we're heavily involved in the open source. Alex is my Arquillian hero. He just knows everything about Arquillian. If ever I need anything, he's always there for me, and I try to be there for him, and we can both be here for you. Why are we talking together? Shameless plug for the book that we've just written. It's in pre-release. You can order it now. A lot of the talk today is going to be about things that we've written in this book. It's taken how long to write this book, Alex?
Yeah, maybe. No, it's like, I always say that this book is like Sagrada Familia. It's
forever. And I kind of got involved with hey, Andy, could you just write one chapter and review some stuff? And I think 4 chapters later and reviewing the whole book. We've worked together heavily on this. So if you're interested in this subject later, a lot of the stuff we're going to be talking about is in this book. Obviously, we want to know about microservices. This is for beginner to intermediate. So we're going to be talking about what we think of microservices and how we think you should be testing your microservices. People will have differing opinions. But we need to know from the get-go what a microservice is, or what we feel a microservice is. Obviously, it's going to be something small enough to run in a Raspberry Pi. No one's shaking their head. That's rubbish. It doesn't have to run in a Raspberry Pi. A microservice is something small, but its underlying infrastructure will be quite large. So we need to talk about the anatomy of a microservice. What do we feel is the anatomy of a microservice? And I love this slide. This is basically, we're still in kindergarten. We're still in preschool. Everyone's still learning what a microservice is. There's no one out there that says this is a microservice and you will not do anything outside of this box. We're still playing outside of the box. There is an initiative going on for Java EE or EE4J, and there's a microprofile project. It's kind of a landing site here at microprofile.io for many vendors that are involved in defining what EE believes a microservice is, how it should be configured, how we should speak to the thing. And that has been transitioned to an incubation project at the Eclipse Foundation. So if you're interested in understanding how microservices are going to play a role in the EE community, then pop along to there, read all the information that's available there. So let's start to look at what we think is a microservice. Initially, you're going to have some kind of resource. What do I mean by resource? This is the end point. This is the access to your microservice. And this, for me and many other people, is the micro. So it's the exposed surface area. It might just be one endpoint, one RESTful endpoint with one that takes one parameter. Nice and small surface area. So that's the micro of a microservice. Things that can be underneath it. So We have controllers, which are optional. We'll get onto that in a second. We're going to have the domain, which contains that business logic. And this is just very, very standard program design. You're going to have some kind of repository. By repositories, we mean persistence, whether that's a simple file or a ORM system. It's fairly irrelevant. We're just going to have something that talks to some kind of persistence layer. And then optionally, with this controller, we have gateways. And a gateway is talking to another service. So that might actually be another microservice. It could be something like SAP. It could be any other kind of service you can think of. And this basically forms the fundamentals of a microservice. You can add bells and whistles to this, and people will add and say different things about this, but you're going to find all of these things in a basic microservice. And as we know, if we're using our ORM with a big database underneath, that could be huge. It could be gigabytes. So, get away from the feeling that it needs to run on a Raspberry Pi. It's nice if you have a service that runs on a Raspberry Pi because you can demo it quite easily. But your microservice might be gigabytes and gigabytes of data and code. The surface area is what you need to think about when we're talking about microservice, and we're exposing this micro surface area of our application, and we need to be able to test that thoroughly. Testing evolution. So we started with just manual tests. Whoa, they're quick, Alex. We progressed basically through various kind of testing mechanisms. So when we started with manual tests, we were talking about people just writing their own code. There was no framework in place. People started to understand that people accessing our code needed to be sure that when they access our code, it was going to do what it needed to do. And eventually we had some kind of unit testing framework that was developed, and people started using testing frameworks. And then within these frameworks, they started saying, okay, we need some kind of design pattern. So we have TDD and behavior-driven development, so test-driven development, behavior-driven development. And we started to realize testing was actually an integral part of developing an application. So you didn't just write an application and then testing. You started with testing and then wrote your application, which is a very good way of ensuring that the application that you build functions in the way you're expecting your test says it should work. And then we need to be testing in production. Virtualization is the next layer, which we'll be talking about later, but this is, now we have a microservice that's separate, and we have another microservice that's separate, and we need to interact with these different services. But when I'm testing service A, do I really need to have service B running? If service B is a very complex service like SAP, or a simple JDBC call to a database, do I need the database or do I need SAP running? Obviously, if I'm testing, it's not really practical to go to your employer and say, can I have a cheap copy of SAP to test against? I don't think you're going to get that. But what you can do is run tests against the SAP, record that information and play that back, and that's service virtualization, and we'll be talking about that in depth later. And then testing in production. So now we have these services. We don't just have this big one monolithic application that we deploy somewhere. We have tens of applications that we need to deploy, and they all need to work together. And so when we deploy those applications, we need to make sure that they deploy properly and that they can talk to each other properly. And so we have to test the deployment of our applications now. So what does this mean in terms of testing? Well, we have different types of tests that we now need to employ within our applications to make sure they're going to be working. We're still going to have unit tests, so we're not getting rid of stuff. Everything you know about testing today is still current and valid in the way you test your application, so no one's going to say you have to throw something away. It's going to be expanded upon. So everything you know and love today about testing, I hope you love testing, is going to be consistent throughout your application. We have the next layer of component testing, and that's things like running an Arquillian test where we fire up our application server and we deploy our application in its entirety to that application server and test the life cycle of that application and make sure that's working. We then have integration testing, which is where we would fire up our application and make sure that it can collaborate with its collaborators. So if I have a database I need to talk to, then I would have a test that simulates the database, either in memory databases or a file-based database locally for the test. Or it could be I need to talk to SAP and I would have stubs in place to talk to SAP or pretend to talk to SAP. The next step from that will be contract testing. This is where, like I say, you need application A to talk to application B, and application B should be responding in a certain pattern or a certain way, and we can record that information. So when service A is talking to service B, again, partly virtualization, contracts are something we put in between and say that this is expected and this is the response. And so you can actually design the way your applications talk to each other through testing. And again, deployment, we need to test for deployment, and we need to test in our production environment. The goal, obviously, this picture is propping it up. We're propping up, our tests are propping up our application. We all have the same goal, all the tests have the same goal, and that is to ensure the quality of your application, and also to allow the safe future development of your application. So if you're constantly testing all aspects of your application, you make some kind of change, if you're testing properly, you can ensure that that change doesn't break something and you have some kind of regression going on. The micro profile is this initiative for EE vendors. It's not necessarily just EE. We are incorporating Spring into the way we do things, Spring Boot. And we're going to be showing you tests in various environments. So it's this collaboration needs to work across vendors, and we can't just say you have an EE test and it can't in any way talk to a Spring Boot test because they're in competition with each other apparently. And vice versa, if you have a Spring application that talks to a EE microservice, then that needs to work in every case. And so we've built lots of examples using various technologies just to show you that there is no bias in any direction when we're testing everything. When you see this, we're going to give you opportunities throughout the talk to ask questions, so we'd love to get some feedback on the things we're talking about. You'll see this slide several times throughout the talk. Every time you see this slide, then obviously we're going to welcome questions, and we'll respond to them as best we can. So any questions? I have one. I can hear you, yeah. Absolutely. So we're talking about contract testing. The question is about contract testing, recording and replaying of responses, invention of scenarios. Can we do negative testing? Can we have scenarios that break or try and break our application server? Yes. That would be obviously negative testing for contract tests, where you would specifically tailor a response designed to try and break your application server, and you see how it responds. So you're not only doing positive testing where you're testing what you're expecting to happen, you should also be testing things that you don't expect to happen. Any more before we move on? 250 people and only one question. No, I'm sorry. I'm going to give you back to Alex. Alex is going to talk about unit testing. Like I say, it's beginner to intermediate, this talk, and there are various people out there that need to understand what unit testing is in detail and how we best do unit testing. And we'll be progressing throughout the up to 3 hours, so we might not keep you here for a whole 3 hours. Lock the doors. Can you lock the doors? Great. No, you could obviously get up and go whenever you feel it. We'll have, well, we're going to have 2 breaks in the talk. After about an hour, we'll have the first break for 15 to 20 minutes, and then we'll have another break later on. So, Alex.
Okay, yeah. Now, yeah, we're going to talk initially as unit tests, because usually this is the first test that you should write. But the truth is that from the point of view of microservices, there is nothing new. I mean that if your microservice or your monolith application is designed correctly, then there is nothing new. It's exactly, you don't need to do anything different from microservices or from monolith. And basically, as most of you probably know, unit testing is a testing technique where the code of the application under test should be the smallest possible snippet to produce the required behavior, right? If you come from C, this usually this smallest snippet was a method, and usually in the oriented programming, it's considered that the smallest part is a class. But there is one guy called J. Fields, which is a guy from the TDD ecosystem, which says, or they split unit tests into two categories. The first one is solitary unit tests, which, as the name suggests, is the solitary unit test focus on testing the unit or work in an isolated or controlled way. So it's just, you can think about just, you take one class, you mock all the dependencies, and then you run the test for this class. But also there is another one which is called sociable unit test, which, in contrast of solitary, in this case, the class under test also uses its dependencies and collaborators, the real dependencies and collaborators. Then this doesn't mean that you are transforming your unit test to a component test, because one of the things that identifies the unit test are the speed. So if you have one class that does something and has one dependency to another class, and this class is also really fast because they do some fast calculations, then you can test them together. It's fine. This is a sociable unit test.
So normally we work independently from each other, but every now and then we give each other a hug.
No. So
didn't mean to scare you there.
Even if you are using sociable or solitary unit tests, at the very end, probably you have some dependencies which are, let's say, hard to write a test together with the main class, or they are really slow. So you need a way to simulate these collaborators, because if not, you will receive a null pointer exception, right? And how to do this is just using test doubles, and test doubles just replaces a production object to one for testing purposes. And in this sense, there is a lot of different test doubles. We have dummies. Dummies are just classes that are passed as argument to a method, but you don't do anything. It's just so your test can compile. We've got fakes, which are some kind of implementation with shortcuts, and I think that the most let's say used and popular one are those embedded in memory databases, right? Like H2 or HSQLDB, which basically they are fakes because they are not ready for production. Although some people use it in production, but I mean that in general they are used for testing. Then we have stubs. Stubs are like classes that they store the state for a future state verification. So it's like they have some kind of memory of what's happening behind the curtains. Then we have mocks. Mocks are pretty similar to stubs, but the mocks do runtime behavior verification. The state is never stored. So you can say, I've called this method, but you cannot say something like, give me all the values that has been used calling this method. And finally, we have a spice, which is like a mix between a stubs and mocks, or it's like a mocks with some kind of memory, which allows you, which records all the information that happened on that object. But I think that most of you will agree that the most used test double is mocks and fakes. So this is a unit test, and this I know that it looks quite strange. First, because I'm not using the camel case notation. Notice that I'm using these underscores and start with should. I do this because it's really easy for any reader to read what is the purpose of this test. You should put should find composers by name. And also, if you put these underscores, it allows you, if this test throws an exception, really easy to check in a long log where is the test that throws this exception. And I also see that I'm using the given when blocks. Although this is not a BDD test, it could be, but it's not. I like to put these blocks. It clarifies a lot what is the purpose of the test, and any reader knows exactly what is the purpose of the test. Yeah, it's a readable name using the BDD style. And finally, the most important thing on a test it's an assertion, because a test, I mean that almost all tests has assertions. And you can do hamcrest or you can use hamcrest plus JUnit, but I guess that the best way is using AssertJ, that we are going to see now an example, which allows you to put a really concise way what is the assertion or what is the verification part of the test. I don't know if you have any question regarding unit testing or AssertJ. We're going to see a demo, so no worries. Okay. As I said, AssertJ is like the best of hamcrest and fixes the wrong things that are on hamcrest. Basically, AssertJ uses a DSL approach, and this means that it detects the types of the objects that you want to assert, and it offers you the suggestions of these methods. And this is really different from hamcrest. In hamcrest, you need to remember that you have contains hamcrest matcher, you have is hamcrest matcher, and so on and so far. But but AssertJ just allows you to give you all the methods just for these kind of types. And this means that it's IDE friendly. So you just do control space and you will get all the methods. And just see here, the first thing that you need to do for an AssertJ test is put this static method, which it says don't use the assert.JUnit static method, but uses the AssertJ1. And notice that the assertions are really readable. You can say something like assert.Moser get name is equal to Wolfgang Amadeus Moser. It's much better than assert.Moser get name is Wolfgang Amadeus Moser, for example. But you also have other problems. For example, if you don't want to stick on the equals method, notice here that Moser is an object, it's not a string, and I want to just assert that the name is Wolfgang Amadeus Moser. I don't want to use the equals implementation of the composer class. So you can do something like returns Wolfgang Amadeus Moser composers get name. This is a Java 8 Lambda. So it's much better than what happened with hamcrest, where you need to that by default, it relies on the equals implementation, which sometimes is okay, relying on equals, but sometimes your POSIX contains an equals that are great for production, but not for testing. This is another example with a list. Notice here that we have assert.operas. Operas is a list of opera. So you can say assert.operas, and then it just have this has size 2, which is just a method that just are available if it's a list. If it's in a string, has size, it's not there. Then then you have this extracting, which says, okay, instead of having a list of operas, I want to have a list of the names of the operas. So basically, what we have in this method is just iterate through all the operas list and get name and return a list of strings. And the good thing is that then you can just use contains exactly in any order and put here the strings. And this method contains exactly in any order, in this case, requires the strings. You cannot pass here an integer because the list is in a list of strings. Notice now that, well, in here you can see that I have like two assertions, the hash size 2 and that contains exactly in any order the two operas. What's happened if hash size fails because I have 3 instead of 2? The test will fail. Then I will go to a test and say, oh yes, sorry, now it's like 3 operas, so I'm going to put a 3. You put a 3 and you run again your test. But then you missed that contains exactly in any order has 2 operas, not 3, so it fails because it says, I miss 1 opera. So you need to go there, fix this method adding the other opera, and then run again the test. If there are 2 assertions, it's okay. If there are 5 assertions, then you start, like doing, I run the test, fails, I fix 1 assertion, run the test, fails, I fix again the assertion. So AssertJ has something called soft assertions. And basically what it does is just like this. You have sort assertions dot assert softly. And this is a Java 8 lambda. And then inside here, you just put all the assertions in a block. And what's happening now is that if 1 assertion fails, it doesn't matter. It just continues with the other assertion, and so on and so forth. And we'll execute the 4 assertions. After that, AssertJ will check if any of these assertions has failed. And if it had failed, it will report as a failure and say, look, this assertion and this assertion has failed. So you can go there, fix them at once, and then run again. So you avoid this round trip of running, fixing, running, fixing, running, fixing, which is quite great. And finally, we have assertions. In case of using a JUnit, usually what you're using when you want to test that your code throws an exception is using this test annotation, and then it has an attribute called expected, and you put there the exception that it's expected to be thrown by the method. The problem with this approach is that probably your test has several lines, and you cannot say, this is the line that thrown the exception. So maybe the exception that you were expecting was thrown by some code that you didn't expect to throw that exception. So what have AssertJ is a better way to do it, which is like using this catch throwable static method, where it has a lambda, and you put there the method that you think or where you expect that the exception should be thrown. And then you simply just do assert thrown, and this thrown is the throwable object, is instance of illegal argument exception and with fail message, and you put there the fail message. So it's quite readable, even better than just putting expected class, and even more readable than just put try catch on your test method there. I mean that probably some people while doing is just putting a try catch in the test itself and then put it a fail if the exception is not thrown. It's a workaround to do it, but not so much readable. I think it's much better, this one. And also it allows you to follow this given when then blocks. Any question about AssertJ? Yeah. 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 Then there is yeah. Yeah, in this case, if you have a duplicate, if it's a list and you have a duplicate, it will try to find 3 objects, not 2. And then it will fail.
Can you repeat the question, Alex?
Yeah, the question is about what happens if your list has a duplicate objects in there, and then you assert. Then if you assert, there is 3 objects, it will fail. You will need to pass through a set, and I don't know it. I don't know. I will check it in the demo. If you have a method which says contains and avoid the duplication.
Yeah, it's a taster, so we're not going to spend the whole time showing you every method in AssertJ. It's just an example of how to deal with collections, and there are specific methods for testing for multiple strings and for random string, so you can have, it contains at least these strings. So it doesn't have to be as specific as this test example was demonstrating. It could be quite fuzzy in what you're querying for. It's just a taster. AssertJ has hundreds of methods for all sorts of things like that. Does that answer your question?
Yeah.
Cool.
All right. If not, we can discuss later or no problem.
Tweet us.
Yeah. So we said that we need to mock our collaborators, and I think that, yeah, I mean that the Mockito is, in fact, it's in the top 10 library used for testing. This is a statistic shown in GitHub. So I think that, yeah, we can say that for mocking in Java, the default or in the de facto tool is Mockito. And basically, Mockito defined itself like a tasty mocking framework for unit tests with a clean and simple API. And this is an example of how you can mock your dependency. You can use, the first thing that you need to do is say that this test needs to use mock. One way of doing this is just using the Mockito JUnit runner, and then just defines with the notation mock, and you put there the object, and then this object will be mock. Also, you can, if you want, you can just use before, and then you do Mockito annotations.init mock this, and then it's just the same, but without using the runner. And from 2. I don't remember exactly in which one, but let's say in Mockito 2, you have a JUnit rule where you can say Mockito, I mean that instead of using the Mockito annotations in mocks, you can, or the runner, you can use this rule, which basically says exactly the same. Find all the fields annotated with mock and do that mocking thing. And finally, if you don't want to use anything and you want to explicitly say this is a mock, you can just use this static method, which is mockito.mock, and you pass the class, and then they will return the mock, this instance of, I mean, at the very end, this is a Java proxy. So it returns a Java proxy.
I would use the Mockito mock within a method. So obviously, the first one is going to be producing the email service for the class that's being tested. You might need to use that in several tests. And if you're just going to be using an isolated mock for one test method, then you can just use the Mockito mock to just literally create a proxy of that object. So it's an intelligent proxy of the object that you're mocking that you need to use in your test class. So you're not testing the mock itself, you're testing something that needs to use that mock to work.
And then how to use the mocks? Well, you just need to just say when this email service must be a mock, said when the mail receive body message with subject, my subject, when someone calls this method with this string, then return, this is my message. This is the recording expectation. Also, you can do something like that. This is a concrete parameter, right? It must be this string. But if you want, you can just use any string parameter, which says just call this method with any string and then return, this is my message. So then it depends if you expect a concrete value or not, then you use this matchers any string, there is any integer, any float, or any object, any class. I mean, that there's a lot of methods with matchers class. Or if you expect the concrete, then just put the concrete object there. And another thing that you can do is verifying the mocks. And verifying the mocks means that you want to verify that some method has been called. Usually this is used when you have some kind of void methods. In this case, I have a mail service, which is mock, and the invoice service is the class under test, which its collaborator is email service. So I pass in the constructor the email service, which in this case is a mock instance, and then I do invoice service.send. And this send method just sends the email, right? But it returns void. So how you can verify that the send message is called, and it's just called once. So what you do is something like put the mock and then verify that the email mock is just called once, and the send message, the method sends any string. The first parameter of send message is the subject, and the second one is the body. So what you're seeing here is that the invoice.send method internally has called send message method of the mocked, in this case, of the email service instance. Also, sometimes, if you see here, I'm saying send message any string and a string. So you said, if send message is called with any string, then it's fine. The problem is that sometimes this invoice service might do some business code there manipulating anything. So you want to be, or you want to verify that these manipulations are correct. And then it's still the same problem. This is the mock used by collaborator, and the send method returns void. So what you need to do is something like this. You need to use one thing called argument captures, which captures the arguments used in the method. So in this case, what I'm saying is like verify that the mail, the mail mock object, which is a mail service, calls once send message and checks that the first argument, which is the subject, starts with invoice, and it doesn't matter the body. So if you call invoice.send method and the email service does not, an email service.send message with a subject starting with invoice and anybody is not called, then this test will fail. So it's the way you have to verify that the invoice service is behaving like you expect. And this is a bonus track. JUnit 5 became GA like 1 month ago. So if you want to use Mockito, you can. Everything that I've explained is still valid in JUnit 5. You need to use the legacy jar file. But if you want, you can use that, let's say, native JUnit 5 extension, which just put extends with Mockito extension, and then you can init all the. You put this, and then you can init your mocks, just putting, for example, as a method argument, and you said init this person, and said when person get name, then return delivered, for example, and then you can use this mock that you've created in your init method in the test as a test method parameter. So you just, that in the first part you initialize the mock, and the second part you just use the mock, and you say that the person get name is equal to Gilbert. This is how it's going to be done, all this mock stuff in JUnit 5. So I'm going to show you now a demo of AssertJ and Mockito. And then it's really simple demo. This is about AssertJ. So I have...
you need to swap screens.
Oh, yeah. Then, well...
It would be a very boring demo if we didn't swap screens. I could tell you what he's doing, but it's not the same.
No. Then, here. Then I have, again, this is the example with the, maybe you don't see everything. Okay. Then I have here the list of operas. This is the same example we've seen. And then what I'm using is the assert.dat, which is that one from AssertJ, operas. And then this is the thing, that if I do dot, I can see all the methods that AssertJ allows me for a list of things. For example, if I do has size, it says, okay, you have a has size or has same size of, but has size is not for a string, so I can do has size 2. And then I can do, again, dot. And I can say, okay, what do you want to say with these operas? I could do, for example, contains this, as you can see, the contains, it expects an opera object. It's impossible to pass here a string or something. If not, it's a compilation error. So you have contains exactly. It contains exactly in any order, contains only once, contains sequence or contains subsequence. So this probably answers your question. So if you have duplicated objects, but you do contain subsequence, here you can put just the sequence without the repeatable objects, and then it will pass as well. Contains all, contains exactly, blah, blah, contains null, but this is the thing about AssertJ. So what I want to do is just extract, and what I want to do is just extract the name. I mean, notice that this is a Java 8 lambda method where I can say just create me a list of strings. And then this is a strings. So with the strings, I cannot do has size. There's no has size. In this case, has size is the has size of the string. Yeah. So if it has been an object, then it's yeah. But if you say contains now it's in a string. It's not an opera object anymore. So you can do contains and contain the super. What contains those? Float and done.
Sure, that's not an A. Sauberfluter.
And that's all. Then I can run the test. And if well, no worries, this is. Obviously, I'm not German, so. No.
Neither have I, but I lived in Germany for 30 years. Just picked up a little bit.
So yeah, no, it's great. So really easy. AssertJ helps you improving your testing skills just doing control space. The other example I'm going to show you here is one for mocking. This is an example that you find in the book, which you have a game service.
Which book's that, Alex?
Testing Java Microservices. Basically, game services. Basically, the example is about a gaming platform, and the game service just connects to AGDB, which is Internet Games Database, like for the movies, but for databases. So what it has this method is just do something like I have an AGDB gateway, which is the gateway to connect to this database, but also I'm using here a games AGB. In fact, it's a local AGB, so it's a proxy Java object, no remote call or whatever, which uses a database. So what I do here is like saying, when I want to search a game, I search first I mean that these games act as a local cache. So what I say is like, if someone has already requested me this game from the AGDB, instead of going outside my boundaries, I'm going to my database and I get it. So what I want to test is that a short return game if it's cached in internal database. But my game service, of course, needs, that in this case, I don't want to use a sociable unit test because games requires to prepare the database, boot up the database, and so on and so forth. And of course, HTTP gateway should be mocked because I don't want to access all out of my internet or my boundary of tests. So I need to mock all these kind of, these objects. To do it, in this case, I'm going to use the Mockito JUnit runner. Then I'm going to mock games, and I'm going to mock HTTP gateway. This is the first thing that I need to do. Then, basically, here is the game, which I'm trying to find the Zelda game. And finally, what I need to do is record the expectation. And what I need to do is when games dot find game by ID, and the ID, notice that is 123, which is this ID. then return optional, because this method returns an optional, because it might be there or not, of game. So what I'm saying here is like, when I call games, find game by ID, just return me a game, a real game, so I know that it's cache. Then here, this is the game service, and I need to set these collaborators inside the real instance. So I just need to do game service.games equal the games, and game service. Okay, now we've got almost everything in place. Notice that, I mean, that this test will pass, and it works as it will work if I run it, because it will return the object Zelda. But you don't know exactly if this game came from the cache or not. So what I want to verify is that the HTTP gateway is never called. So I can call verify HTTP gateway times 0, so it's never called, dot search game by ID, and it's any ID. So what I'm doing here is just saying, just find me the, run the code and really verify me that HTTP is never called. Notice that this is since it's a mock, you will not receive a null pointer exception. So you need to verify it explicitly. So now I can run it, and it's green. So now I'm verifying that my logic of checking if there is a cache object or a cache game, then return the cache game, and if not, go to the HTTP. The first part is validate. Of course, in a real environment, you can see here there is more tests that say should return game from HTTP site if game is not internal database. So what I'm doing here is just saying found game search by ID returns Battlefield 4, and then I'm also mocking the HTTP, saying find game by ID 123 returns an empty, so it's not in the database. And then when I just try to call HTTP, then returns me the game. So then here with a unit test, really fast unit test. Remember that this is a unit test. You can verify this logic really quickly. And now, just the big. So any question about this demo? Yeah.
Sorry, can you repeat that?
Yeah.
This is kind of an initial approach. So the question is, do we want any kind of interaction outside of the test? And for this test, no, we don't. So that's the purpose of Mockito, is to contain our test environment. If we wanted to go outside of the remote boundary, then we would need to ensure that that service is available, and that then would be more an integration test than a unit test. So we want unit tests to be super fast. So yeah. Unit tests are the tests that developers run all the time. When I start running deeper integration tests, when I start interacting with my collaborators, and I keep going back to the SAP example, but it's kind of a real world example. If I wanted to talk to SAP in my unit test and SAP was not available at that particular time, then my unit test would fail and it would give me a false positive.
No.
So I need to mock out SAP and say, this is the class that normally talks to SAP. I'm just going to have the mock. All I'm doing is verifying that my class that interacts with the SAP mock does what I'm expecting it to do in a really quick way. So it's kind of the first step. It's not going to replace going outside of that box. Eventually, we will need to go outside of that box to verify the functionality of the object in a real-world scenario. But this is that's going to take time, and these tests are tests that we want to run really, really fast every time we do our build, basically. And they don't. If you're a developer and you're sat at your machine and you're running 100 tests, you want them done in a second. So this is what Mockito is for, is to say, okay, all this slow stuff, we'll mock that out, all this functionality that you don't really need just to test this specific object, that's all hidden, and we'll replace that with canned responses. And those canned responses are obviously in code. They're super, super fast. So these tests run in milliseconds.
Yeah, this is just, so it's unit tests, and they are really important to be really fast. But this is not, unit test does not replace anything. As we said in this slide, all the tests are pushing the same. And sometimes, I mean, as Andy said, that then we are going to, in fact, Andy now is going to cover this component testing, which you're going to cover how to run this in a more real environment, let's say. Unit tests also are really important for if you are using continuous delivery, because you need really fast feedback. We're going to cover this by the end of the session, but it really needs to be fast, because you need fast feedback so the developer knows exactly that his commit has not break anything. So it's really important that they are fast. But now, yeah, Andy was going to...
It's kind of a relevant question. I completely forgot that was coming up. Component testing, sorry. Component testing is the next step on from unit testing. So we have our unit tests. These are things that are really fast, and we've mocked everything out. Now we want to take that a step further. So I have an application. I need to deploy my application to my application server or application environment. Whether that's an EE application server or a Spring Boot environment, I need to ensure that the application runs within that environment. So this is kind of the next step of putting things together in a more collaborative way. So this is where we're using the sociable tests, and we're going to be using our collaborators. Right, yeah. This is a very simple Arquillian test. I'm actually going to do a bit of a demo at the end and show you how that all works together. But very simply, we're running our test now with the Arquillian class. And this basically understands or defines parameters or a framework for us to test our application in. So our application classes have now been unit tested. We need to deploy them in our application on our application server and test them in the real world. This goes a little bit further. The test itself, so getColor object, is actually calling a real server. So this test looks really, really simple, but what's going to happen is the deployment is going to build a real-world WAR file, and it's going to deploy that to a real-world application server. It's going to generate a real-world client call test against that application server. So this is very simple test, but it actually has a huge amount of boilerplate code that's hidden in the background, and we'll be looking at that in a minute. So yeah, Arquillian, I forget we have these annotations. Injects the URL. So the URL is obviously going to be required to access the application server, because the application server is running under a specific context. We don't know what that's going to be. Usually we generate a random port for the access, and so that gets injected here, and I can use that injected URL at this point to make the real world REST call over my local network. So we're still not going outside of our own box. We're not testing any services that that are deployed externally to our server. We're testing and starting a local application server and testing it locally in our own network. Same kind of thing for Spring Boot. So we have the Spring Runner, very, very similar in the way that Arquillian fires up an EE application server. This is going to start a Spring Boot application and sew all this in. We still have our mock servlet runner, so we don't want to go outside of our own network, and the mock servlet runner basically allows us to speak over the network to our local machine. And auto-wired is obviously inject in the Spring world, and we test against that. Spring Boot REST application requires us a little bit more, and again we have all these examples available later at the end. So if you're missing something here, don't think you need to write all this down. You'll get all this later. But this, again, is just saying start up my test environment on a random port, and then I want to do a real-world call, and we use the template, so the test REST template from Spring basically gets the URL injected inside it and knows how to talk back. So the Arquillian test injects the URL directly into the test. Here we're injecting a test REST template that allows us to talk to that instance. And it just makes a REST call. Wildfly Swarm is supported by the Arquillian framework, but we need a active default deployment annotation, and that is just something that triggers Wildfly Swarm to scan for classes, and it builds that test. So it's very, very similar, and it ejects, and we can test against that test. And then Vertex, which Alex is involved in heavily, I believe. For this, we need the Vertex unit runner. So again, you can see we're just adding a run with annotation and then telling it what we're going to run against. And obviously the Vertex runner and the Spring runner and the Arquillian class, they will fire up and they are doing some fancy class path scanning, and they will find all the dependencies, fire up the corresponding application servers or environments for us to deploy our application in, and then we test a real test against those environments. And in Vertex, you also need to shut down, so we need it after to clean it up. Otherwise, it starts a process that will hang in the background, and it needs to be told to shut down. We've got the Tommy Jack's OS starter project. It's just a really simple project. I can probably just do it here, actually. Where's your console? Yeah, I just need to select all that. I'm not a Mac user. I have a nice little Dell. And it just opened up a console for me. I just need a console. Yeah. So this is basically just downloading this simple little project. I can open it up in ID as well.
Right. You want to open it?
Yeah, I just need to open it. This is the first time we've done this talk, so we're working this stuff out. Sorry. Or you could just switch my computer on. Okay, I wanted to do this in real time just to show you that this is a really simple project to download yourselves. And it will import, and we can just run it. Class bar scanning. Is it me, or has IntelliJ got really slow when it starts applications these days? Or loads projects? Don't go to sleep, not yet. And those of you who are, wake up.
Well, actually, I think that the problem is that we are downloading internet twice. One in the console and another one by IntelliJ.
I tell you what, I'm just going to swap over to mine.
I mean, well, yeah.
Yeah. That should be quick enough. here. So this is the project. It's very, very simple. I don't know why it's taking forever to load on this box. For me, this is the very beginnings of microservice. So it's just a singleton EJB in this context called color service. It has one endpoint for colors. So this is the surface area I was talking about with a microservice. What is a microservice? It's that surface area. This is, for me, the microservice. It doesn't do anything fancy apart from take a string color and return a color object. It could be making a database call. It could be making that famous SAP call. But here, this is just all very much in memory. Very simple application. And to test that application in Arquillian, I have my color service test. And this is just going to be the Arquillian class. So annotated with run Arquillian. It's a standard unit test, but in this case, I'm making a deployment. So I need to do some kind of deployment of my application. And to do that, we use shrink wrap. Had a bit of a discussion with Antonio last night about Spring Boot, and I kind of like the idea, and it's something I'm going to be talking with Alec, which is more about class path discovery of our application. So a nice thing with the Spring Boot test is you don't need to define any particular classes for the test. It will just discover those and deploy them in the Spring Boot context. Whereas with EE-test, we actually build our war archive or enterprise archive. And for that, we use shrink wrap. And so shrink wrap is literally just adding some classes. And it's going to be those classes that... I'll just make this a bit more visible. So the color service and the color class. That's enough for my application to test against. And what this is doing is actually, in real terms, is building that war file. And it's going to ship it to the application server and then run a test against it. And here's that web URL getting injected. And here's a web client accessing that URL. And so if I just run this, which is just going to be a Maven test, and I'll expand this.
You notice here how the Tommy is starting?
So this, if we scroll back through the log, you will see what it's actually done is fired up a Tommy server in the background. So this is the actual server starting up in the background, and it deploys the application. Trying to find the endpoints.
I think it's after CXF.
Here. There we go. So this service URI that you can see, that's the real endpoint. And you can see it's on localhost, and it's generated this random port 33351. And this is why we need to inject the URL into our test. And this is kind of the magic that's going on in the background. So this is an application server that's fired up. It's deployed a real war file to the application, and it's now available under this big, long URL. And this URL gets injected into my class. It then tests against that, a test, and shuts down the application server. So although that test looks really, really simple, that's the idea. It's designed to be something that looks really, really simple.
Yeah, also notice that it just takes 8 seconds. So we are just creating the Word file, booting up a Java EE server. I mean that if you compare with, not nowadays, but in the past that were really, really slow to boot up a Java EE server. Now this is a Java EE 7 server. It just boot up, run the test, and shut down, and with just 8 seconds. It's really fast.
So that is basically a component test. So I've taken my application, we've unit tested. Obviously, this color service and color you've just seen in a unit test. We would still have a unit test for that. This is the next step where I'm actually putting it on my application server, deploying to a real application server, and doing a real local network test against that service. So we go. Switch back, and we go back to our slides. So, any questions on a Arquillian component test or a Spring Boot test or component testing in general? It wasn't that dry, was it? Oh, there's one. Good. So the question is, what if I have thousands of classes in my application? Well, yes, I'm going to have thousands of classes in my application and can shrink wrap load those classes. Or do I have to manually enter all those classes? Well, the answer to that is very simple. No. Shrink wrap is a really, really powerful mechanism. It understands pretty much everything that Maven has to offer. So it understands POM files, it understands class path dependencies, it understands libraries. So I can add using shrink wrap, that was a very, very simplistic example, just adding my two classes. I could also add jar files if I have in my libraries directory, in my application, I can add all those jar files. If I have an application that I'm writing, normally the shrink wrap, I would create an abstract class with that shrink wrap that contains the bulk of that logic. And then I would extend that. So I'm returning this war file, this war archive, and I can then add to it. So in my abstract class, I would have my larger application and the wiring required to build that application. And I don't have to add my entire application. I can also add dummy files to mock out specific functionality that I don't need for that test. But if I want to be as close to my application scope as possible, then I'd build my war file just as I would expect the Maven War plugin to build my war file. I would try and build that in shrink wrap in my abstract class. And then for each test that I'm testing, I'm only going to add a few classes to that shrink wrap that is delivered from the abstract class. So it's a kind of write once and reuse kind of scenario. But I can also just import my whole POM file. So this was the conversation I had last night, which was, Spring Boot just scans the path and has stuff. And my question was, well, how do I exclude stuff? And it says, well, we don't. I think I like tests to be more specific than that. And I still think it's a really good idea. And I think it's something we could probably do on the shrink wrap side.
Yeah,
it's just scan the path. I mean, we can import the whole POM file. And,
there are several strategies in this way. For example, Wildfly Swarm, we're going to see now that it has this scan class path like a Spring Boot. Also, I would say that in a component test, probably you don't need to add a lot of classes. Maybe you need to add 10 or 12. If not, probably you're getting close to end-to-end test. But then in any way, in this Spring Wrap, you can do something like add me all the classes from this package and recursively sub-package as well, so you can put just the package, or even you can do something like call Maven or Gradle. I mean, it works with both, but let's say Maven. Call Maven package, get this war file, put it me in this room wrap file, and then just deploy this war. So if you want to do an end-to-end test, you can even generate your war file on the fly and on the test. Of course, in this case, you are paying the time of the running time of the test, because you need to run all the build, get the war, and then run the test. But yeah, I mean that you have several strategies in this way with this room wrap.
Did that answer your question? Any more questions before we move on? How robust is component testing? It's a good question. I think obviously unit testing is the most reliable and quick kind of testing. I wouldn't be running these kind of component tests unless I wouldn't be running them in my regular build. I would have them separated from my regular build because they tend to be slow. I mean, 8 seconds for the application to start up and do the test and shut itself down is quite quick. And if you run a whole bunch of tests, so the killer is obviously starting the application server. Arquillian is now very, very mature. How long have we been developing Arquillian now? It's probably 8 years.
Yeah.
So it's initial inroads, same as any software, were buggy, but over the years it's progressed. And every single EE application server that exists on the planet is supported by Arquillian now. And they kind of know, so the vendors write their own startup routines for Arquillian. So Arquillian is the framework and we write the runner. So for Tommy, for example, we've developed our own plugin for the Arquillian runtime. We know how our application server starts up. We know how to configure it and make that run fast as possible for a test. And so the environment that's been initialized through Arquillian is done by the vendor, and Arquillian is like the initiator of, do your startup and do your shutdown and do your deployment. They don't have to understand how they do that. The vendors do that. But all vendors have plugged into this system because it's become so popular now. And I really don't think there is an EE server.
Even EE server and servlet servers, for example, Tomcat or Jetty is also supported by Arquillian. So maybe you have just your application with Tomcat and servlet, and that's something.
To answer the questions, they're very, very stable now. These tests are just slow. So I would describe them as slow, and I wouldn't want to run them for every single build that I have. I'd have them in a separate module, and it's more of a it's a component test separate from a unit test. And I usually run them on Jenkins. So when I do a commit, it will run all the component testing for me. But what I was about to say is that the killer is the startup of the application server. If I have 1,000 tests, I don't need to restart the application server every time. I have the option of leaving the server running, and then the tests are just deploying a trivial WAR file to that application server. And so that 8 seconds for just one test that we saw here, that was a cold start. If I run that again now, it would probably be a little bit faster and become progressively faster. But if I was running thousands of tests against that server, they become very, very quick, less than in milliseconds, the deployment and testing against an application server. It's the startup and shutdown of the application server that costs. But yeah, stable. And I think with that, I'm handing back over to Alex for REST API.
Yeah. So you have seen here that we are starting the application server, and then we use the web client. This web client comes from the Java EE spec. Maybe you are not using the Java EE, or even you want something more oriented to test, because web client is oriented for production code, not for testing code. Of course, usually your communication with microservices is using REST. Creating a REST API with JSON or XML. I know that this is something that a lot of people do, but it's not. That there are other possibilities like there is binary protocols or even message brokers using a binary protocol, like for example, it's doing it with Vertex. But I would say that in most of the cases, we are implementing the communication between microservices with REST. So I think that the best tool for verifying REST APIs is REST Assured, which is a testing and validate. It's used for testing and validating REST services, and it's inspired in Groovy and Ruby test way, right? And REST Assured it's just the way of testing the resources part of your microservices.
I think it's fair to mention right now that there's no golden rule that a microservice has to be a RESTful endpoint.
Exactly.
The resource, the blue resource at the top, that can be any kind of endpoint that you need to publish as a service, as a microservice. But the industry is kind of taken a huge step in the RESTful endpoint direction. I think that's where your focus should be on providing RESTful resources as your microservice, because everybody knows how to talk. It doesn't matter what language you're using or what scripting you're using. Everyone has something that knows how to talk REST these days. If you have something that's not REST, then you're going to have to do the groundwork to make that test work for you. And this is a standard way of doing stuff.
So this is an example of REST assure. Basically, what you start is with given when, and then you put here the HTTP method get. This is the HTTP method it's get. Then you can put, or you can use a placeholder which is replace it on runtime, and you can put something like get composer having Ludwig van Beethoven, and then you have assertions with the response. And you said assert that. So what this does make this internal is just doing a connection to HTTP localhost 8080 / Ludwig van Beethoven, and then the return must contain a JSON file which the body is name and should be Ludwig van Beethoven, and you can even use JPath expressions inside this body. So you can say operas.size because this JSON has an operas field of type array. You said operas.size is 1 and operas.name, and this is doing exactly the same as with the example we saw in AssertJ. It just takes all the opera objects, just create a list of strings with the name, and then has items Fidelio, because it's the only opera that Ludwig van Beethoven wrote. Of course, as I said now, by default, REST assure goes to HTTP localhost 8080, and if you want to specify another URL, you can just do .get http example.com / and then you put there the placeholder, which is great, but notice that if you have several tests, and if you change example.com to example2.com, you need to go to all your tests and change the example to example2.com. And to avoid this, what you have is a request spec builder, which is a way to reuse the same configuration across all the requests. And you can reuse the expectations, the path, the root, the authentication methods, the port, the host, the parameters, the headers, everything can be reused with this request spec builder. So basically you do request builder, a spec builder, new request spec builder, you then put builder.setBase URI and just put example.com, and then you just do given.spec builder.build, and then as you do, as we saw in the last example. So you can put this request spec builder inside a factory method, and then this method is called to get always the same request spec builder, and you pass this request spec builder on your test. So if you change from example.com to example2.com, you just need to go to where you have defined the request spec builder and just change there the base URI, and all your tests will be adapted automatically. One of the great things about REST assure is that they have integrated all the authentication things, so you can put, for example, if you want to use OAuth2, you can do given auth2 with the access token when blah 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 blah. So all the authentication, it's encapsulated inside REST assure. And again, this auth thing can be put inside the request spec builder. So if you use the same token and the same OAuth protocol in all your REST endpoint, you just put it on the request spec builder and everywhere is updated at once. And you can use also the form and the basic way. It also supports CSRF token, and you can even implement your custom authentication method. And, well, more features about REST assure is that you can implement your custom parsers. So it's not just for JSON and XML. You can implement your own protocol as well. It has one of the great way of REST assure is that it has an SSL support. So usually when you start doing HTTPS, you get a lot of exceptions with certificate is expired, certificate is not validated, and so on and so forth. So you can do just .relaxed HTTPS validation, and then all HTTPS connection works perfectly without all these security mechanisms that are behind HTTPS. You can also use filters, so you can modify the input and the output of the content before and after is sent or received. And finally, it has some JSON schema validation. Just schema validation is like XSD, but for JSON. And you can say, look, I want to validate that my JSON has this structure, but I don't care about the real values. So say I want to be able to verify that it has a field called name and it's on a string, and I have a called field age, which is an integer. So it just checks this, don't check about the real values. So it's also supported this by rest assured. Let me show you now a quick example about how to do this. This is, everyone knows Wi-Fi swarm, what it is? Yeah? You don't know? Yeah, everyone knows Wi-Fi swarm? Well, Wi-Fi swarm is like a Spring Boot, but for Java EE. Okay, so it's like creating a Uber jar with all the stuff there. And this is a really simple endpoint, which is just the one that I've shown you, that you go / composer and you find the composer and returns the answer. And this is the test. That in this case, I'm using the Wi-Fi swarm approach, which Wi-Fi swarm is focused on microservices. So you can use that as a ring wrap thing, but you can use also this default deployment, which says just scan the class path, put everything from the class path inside this WAR file, or in this case, it's a jar file. And in case of microservices, probably this has sense because they should be small, so it should not be really take a lot of time to deploy everything. So, as I said before, you can do given when. Notice that this is the ADSL. Meanwhile, I'm just writing it. It appears everything. Then you can put here loot wing. Then I can check AssertJJ. And yeah, just I'm going to put the name is wing. So this is also a component test because you are checking that your resource in a real environment works as expected. Of course, the question is, and what's happening with the databases? For example, in this case, I'm not using any database, but if you were using a database, then in component tests, you're using this in-memory embedded databases, which are pretty fast. So now if I run this test, you'll see here that if it works, hope so. Yeah, that it's resolving, notice that resolving 0 out of 5, 4, 5 artifacts and so on so far. It's just scanning the class path. Then it's just starting the Wi-Fi swarm, which underneath is undertow plus Wi-Fi. So it's starting Wi-Fi server. Then it's deploy. Okay, now it's deploying. Wi-Fi swarm is ready, and it fails probably because I miss. No, it fails. Well, because composer looking van Beethoven, because probably right. No. Okay, I mean, that is just that I put an N and then it couldn't find in the internal database. I can run it again, but it was this the problem.
And it's the same with these kind of tests. It's the startup of the application server environment that takes the time. The test is
it's a
millisecond, and we're only running one test. These become obviously far more valid if you're running 1,000 tests against that instance that's fired up. Then they're all going to be really quick.
Then let's continue. Okay, any question about rest assured?
Good. We're going to
wait for 15 minutes.
Yeah, we're going to take a break now.
Yeah. Let's take a break, 15 minutes, and then we continue with. We're going to start with
20-minute break.
20?
Yeah, it takes time to get out of here.
Yeah,
and come back
20 minutes, and then we're going to start with things
we've taken your names at the door and taken pictures and stuff, so if you don't come back, we know who you are. We're raffling off 8 free books at the end, so if you want to stay to the end, then well, you have to stay to the end if you want to get a book for free. There you go. That's bait. Okay.
Let's continue with testing. Now we are going to start some techniques that are really more specific to microservices. If one was more like an introduction, which you can reuse in Monolith or in microservices, but now it's more things that are specific for microservices. The first thing that we're going to cover is service virtualization, and probably with microservices, you have one service, and then you have several other services that you need to talk with. Maybe these services are internal, maybe they are external, but your microservices has dependencies with other services that, from his point of view, they are external. So the thing is that how we can test this. Notice that one option would be I have test A that I have the microservice A that has a dependency with microservice B. So if I need to write a test for microservice A, I start up microservice A, and then I start up microservice B, and then I run the test. This might work, but the problem is that probably you have tens of microservices. So probably you start with A, B has a database, so you need to prepare this database. Then this B has C and D, and you end up by creating an end-to-end test. So to fix this, there is this methodology called service virtualization, with basically it's like a light proxy which intercepts request and response in a smart way. And in a smart way, I said that because they know how to detect if it needs to capture the traffic, the real traffic, or needs to simulate the traffic. And it's really easy. Let's see now service virtualization in capture more mode. Probably this is how you're going to run the first time. So one way you can do it is just simulate your API. Just saying, okay, I'm just going to forget about the service B, and I'm going to write a simulation. The problem is that in this way, it's how you understand that this other service must behave. But it's not how can be really be the protocol be implemented. So what you need to do the first time is call against the real server. So let's say that periodically, every week or every 2 days or whatever, when you think you are going to run a test against a real service. So you have service A that connects to a proxy, this light proxy, and this light proxy, instead of returning you a cannot answer, it goes to the external network and connects to the service B. Then this service B will return an answer. It says, okay, if I go to a /composers or /Ludwig van Beethoven, I'm going to return the real JSON. And then what all these service virtualization frameworks does is just store this in its internal database. And after that, it returns the real answer to your service A. So your test now it's effectively using real service A and real service B. But this just happens the first time. What's happened in the subsequent runs of the test? Then you don't need to hit the real service B. You just have the service A, goes to the proxy, and the proxy will say, okay, you want to go to a /composers /Ludwig van Beethoven, but you have done this before, because I have in my internal script database. So what I'm going to do is find my script, find the answer. I'm going to return you the answer that was returned before, and just say it, and here you have the answer. So now the answer is the real one. although you have not connect to the service B.
So service B up till now, that's been a mock or a dummy class, and we've now spoken to our real implementation, but we want to go back a step because we don't want to talk to service B all the time.
You can, well, you can see now. Then one of the, I think that the best tool for Java, I know that there is also WireMock and Betamax and so on and so forth, but we've tested all of them, and for me, or it's my opinion, Hoverfly is one of the best one for service virtualization. It's implemented in Go.
I like WireMock myself.
It's implemented in Go. It's integrated with Java, and one of the great things about Hoverfly is that when you start it, it modifies all your JVM properties. So all the JVM connection properties are modified by Hoverfly. So you don't need to change anything in your code. And magically, your code will speak to this light proxy. We're going to see an example, but this is in capture simulate mode. This is the life cycle I've explained before. Basically, Hoverfly comes with a JUnit class rule. It also has support for JUnit 5. And just you instantiate the Hoverfly rule.in capture simulate mode, and you put the file that you want to be stored. Notice here that you have my Composer's gateway, and this Composer's gateway is the one that connects to my Composer's service, and I'm using operas.com 8081. I'm using the real host. I'm not putting here localhost or wherever. This is where the real service is running. Then I do the get composers, which is Van Beethoven, and obviously it returns this. It returns the real data, and it's stored. And the store file, it's something like this. That you have a data, and then you have that the request, when you go to /Louis Van Beethoven with method get on operas.com 8081, then just return status code 200 and the body and the headers and so on and so forth. This is the real. Then what's happened when I run again this in simulate mode? Sorry, because no. If I run again this test, then the operas.com is not going to be, you're not going to be connected to operas.com, but you don't need to change the host name, because since Hoverfly modifies all your JVM network settings, he knows exactly how to deal with this. I'm going to see that now in an example. Also, it has some simulate mode, which you can do something like this. Maybe your service B is not done yet. So in these cases, what you do is something like this. I want to start in simulate mode, and I want that always returns that when I connect to api.fly.com with get in /API/bookings/1, then return this JSON file. And probably, if you check this, you said, look, this is like Mockito. But instead of mocking classes, I'm mocking services. So you can think about that service virtualization, and in this case Hoverfly, is like a mock for the enterprises. It's just you're mocking my service instead of my classes. And that's really powerful in cases you don't have the service be developed yet. Again, you just need to use the Hoverfly rule, where you want to store, unload the file, and then just build the request and response programmatically. And as I said, since this is like Mockito, you also have this verify component. So you can verify that you have called any flight host with API's bookings with any query params, or you have called put with this in API booking 1 and with this header. And notice here that I'm using any body. So it means like it doesn't matter which is the content of the communication. Any communication I want to verify that I have this communication with put. I don't care about the content. And let me show you an example. I have here my service. This is the Composer service I'm running with, in this case, in Docker. And then I have And then I have here my test, which this is the music box. This is service A which is a music box, and I want to connect to service B, which is the composers, to get some information about the composer. So I'm just putting here the hoverfly rule. And then notice here that in the composers gateway, I'm putting here the IP. This is the IP of localhost, which is my, well, this IP with port 8081. If I use it here, this is the running service. And then I assert that the composer is Ludwig van Beethoven when I search for Ludwig van Beethoven. So then I can run it. And then what's happening in this test is that I'm getting the real service. I go here, I do the request against the real service, and I get the JSON file. And if you check here, I think that it's...
Yeah, I think it's worth mentioning. This getComposers.json, this doesn't exist until you make that call, and when you make that call, it creates that file, and then the next round, obviously, it finds that file and uses that file. And this is kind of like a one-time thing, so you can get like your safe developer, if you're going to be making serious calls to something like the famous SAP service, you don't want anyone making those calls. They need to know what they're doing, and they make those calls in a safe manner, and they record this information, store all that, and that gets added to the project. And so other developers, they never make that call because that file is in your project.
Then notice that I'm going to shut down my service. So now if I do docker ps, you see that there is nothing running. And I'm going to run exactly the same test. I'm connecting to the host. I don't need to change anything. And then if I run again, you see the test is green as well. And notice it's quite more faster than before because I'm not touching the real service. So without changing anything, I can make the test run. You didn't need to take care about changing the host or whatever. It works magically without touching anything. It just basically it's not magic. It's like changing the JVM network settings, but this is how it works. And notice that this also works pretty well if you are using external services. If your microservices needs to connect, for example, to Twitter API, you can just run it once and then use this test and this data collected for your test. So you don't need to get some flaky test like the network is down, you reached the quota on Twitter, and so on and so forth. We're going to skip the questions. We're going to go to by the end. So if you have any questions, just write down on your, in a paper and then write, because if not, we're going to run out of time. So we've got, integration test. Here. And in the case of integration tests, the goal is to verify that a module can communicate with real external services. This is a bigger test. For now, we've seen component tests, which is like, I can use an embedded database, I can use service virtualization to mock the other service and so on and so forth. But at the very end, you still need to cover that my real database is able to boot up and execute some queries, that my gateway class is able to connect to the real service. And basically what we are going to cover, and it's, these parts, these red parts, the gateway integration tests allow any protocol level errors such as missing HTTP headers, incorrect SSL handlers, request response body. So in the gateways you test these things that are specific to, let's say, production. And in case of repositories, you're going, as I said, to test against the real databases. So if you're using, for example, PostgreSQL, you need to boot up a PostgreSQL database and run some tests against this real PostgreSQL database. So in case of persistent tests, I'm going to show you some tool that you can even use it in your component test. But as I said, the difference is that in component test, you're going to use in-memory database. In this case, you're going to use the real database. This is an example, okay, of how it works. And Andy, I think that it's going to
Yeah, I included this slide. This is like the first attempt people usually have at some kind of integration test with their database. We've just got two methods here: clear database, insert composed data. We would probably have some kind of cleanup routine, and this is a very ad hoc way of doing stuff. No one knows what you're doing. What's in the clear database method? What's in the insert composer's data? So this is like a bad way of doing stuff. This is what a lot of people do without using any kind of framework. They'll go off and create that connection to the database, populate the data, and then test against it, and then clean it up. And when that time comes to hand it over to the next developer, he has to dig into that code and have a look. He has no idea what's going on. So we want to replace that kind of ad hoc way of doing stuff, i.e. the wrong way of doing stuff, with something that's much, much better. And we'll go back to Arquillian. So Arquillian, the project provides this for us. And this is going to be provided by a rule. And this is just a standard JUnit rule. So again, we're back into our JUnit context that we understand and know. All we're doing is adding a rule. And then the DB unit and Arquillian resource inject a database populator. So the rule basically defines where the database is and how that's set up. And then we populate the data using our rule. And this is just a much more standardized way of doing stuff. You're using a framework. It's write once and reuse.
Yeah, it's important to notice here that you don't need the Arquillian runner. Just a rule. It's called Arquillian because it's inside it's behind the Arquillian umbrella, but you don't need the runner.
Yeah, so we don't need to be deploying this to any kind of application server. It's not a component. It can be used in that context, but this is just a standalone context and a very simple way in a JUnit test of populating a database.
And notice that this is the file.
So we're basically using a YAML file with data. We can generate this file and populate the database with known data. So this is our canned data for the tests. And then we use an after rule to clean up, and we can use the same YAML file. So if I've populated the data with 10 specific items, I can remove those using the same YAML file. Obviously, the benefit of using this is there's a huge amount of boilerplate code that's just been done by those very simple tests. We don't need to reinvent the wheel. Basically, that's the idea: is not to get your developers reinvent the wheel every time they need to do something with a database. It's programmatic, so you can program the API, and it supports many different frameworks. So this is not just RDB, relational database management systems. This can be a NoSQL database or NoSQL. I don't know why I always say NoSQL and everyone else says NoSQL, but that's the way I learned it. And we have REST API support. So when the service is running, we can actually query information from the service. And we're going to skip those questions. Why do people skip unit tests? They skip unit tests a lot of the time because they're slow. So we've already talked about unit tests and how fast they can be. And then we go to our component tests and it slows down. And now we're doing integration tests and we're adding services and running up services. These things are just going to get slower and slower and slower. And people want to skip them. And I'm just going to show you an example of the thing that can be kind of built up using this theory. I believe it's this button. I'm going to get it all wrong. So this is a very complicated end-to-end test, and I'm not going to go into great detail on it. It's just an example of showing you. If I can catch that with the mouse, that we can do. So end-to-end test. This test actually defines several rules. And we have this thing called a rule chain. This is just standard JUnit stuff. I've just made a couple of rules, a Redis rule and a MongoDB rule. So I need to fire up a MongoDB for one service and a Redis NoSQL database for another service. and I have another microservice that I need to fire up. And this is just a very, very ad hoc way. I like to say the gloves are off. So I have 3 different services that I need to fire up for this test. How do I do it? A very simple way to do it is using rules and rule chains. I have multiple deployments. So the deployment we saw before in the Arquillian test was designed to create a particular deployment. And here I have my shrink wrap building a much more complicated scenario, and we can see that we're adding libraries. And this is, again, just to show you the depth of Arquillian and the Arquillian testing framework and the things you can do with it. So this has another deployment. And another deployment. So I've got 3 different deployments going on. I've got rules going on. And this is a super, super heavy integration test. But it's kind of what we need to do to test different deployments against different services in a real runtime environment. And I can test in sequence. That's a kind of no-no in unit testing that should be independent from each other, but now we're not independent from each other. We need to be dependent on different services. And so we have mechanisms at Arquillian that allow us to run specific tests in a particular sequence. So I might populate in one test a database, and in another test I might remove that data and assert those inserts and removals. And we go down all the way. Once everything's fired up, I'm just testing that services are available. And then here I've even got a UI test. So this is moving into Selenium and drone testing and actually firing up services for a web application that has a UI that needs to be tested against all those running back-end services. So we can pretty much cover, in fact, not pretty much cover, we can cover every kind of scenario that we have in a microservice and application server context using the Arquillian testing framework. We don't really want to do that. Yes, we do. We don't want to do that when we have a better option. The better option is not always available to people. The better option is going to be Docker. So we can switch back. So instead of having an integration test that tries to fire up all those different services, and again, that's dictated by your environment. The reason we have the complicated scenario in Arquillian is because you might not have the luxury of being able to deploy containers and manage containers in your developer environment. So you need multiple options. And this is where Arquillian Cube comes along. So Arquillian Cube basically integrates extremely well with Docker, Docker Compose, and native Docker. It allows us to start, stop, configure, and deploy containers. So all those services you just saw in that integration test that were being started up by rules in various fashions or deployments, we can take all of those different items and place each one in its own container and start to use Arquillian Cube, which virtualizes that process away from the test itself. We can also, this is more your stuff with the
Spring,
the Cube DSL. So we have the language, programming language that allows us to create different kind of tests. So this is going to be a Spring Boot test, and the initializer is a class that we can use to customize the startup. I'm not going to show you the code. The code's in the slide.
Yeah. This is like where you define what you want to start up before running the test.
So this is the initializer. It's just very, very simply like the JUnit rule that allows us to fire up a container. And this is just an extension that's added. And this is performed before the test is performed. So
this initializer is provided by a Spring Boot. So what you need to do in a Spring Boot is say, look, instead of using the default Redis IP and Redis port, just use the ones provided by the container. Which is like you said, you see that I'm saying Redis.get IP address and Redis.get bind port. This Redis instance is the one provided by the class rule. So what you're saying here is like, boot up the Spring Boot application, but the Redis instance that I want to use is the one provided by Arquillian. This is what you're doing here.
So it overrides whatever's on the class path for that specific test. And this is moving on to the Arquillian Cube example, which is one I'm more familiar with. And this is, again, just taking a very, very simple Arquillian test, or making an Arquillian test look very, very simple. What's going on here is we have a container that's been defined, and it's called Hello World. And just adding the annotation Docker URL is basically going to tell us we need to fire up that container. So the container is fired up, and the request spec builder is the URL, or contains the URL that is connected with that service. So when Docker fires up my particular instance, I need a way of finding it, and the spec builder allows me to find it very easily. And then I can talk to a Docker service in my test.
Yeah, but basically this request spec builder is the class from Rest Assured. So if you want to use Rest Assured, this with Docker URL and setting a request spec builder, Arquillian Cube will configure your request spec builder to connect to the container called Hello World. And I think that it's, if you do next, yeah, this Hello World container comes from a Docker Compose. So if you don't want to use this programmatic way of having to define all your containers in a class rule and define everything, you can just use your Docker Compose files, define everything, and then if it's, I mean, that if it's in source test Docker, or it's in the root, or it's in source main Docker, there are some defaults, you don't need to specify it, and if not, you can go to your Arquillian.xml and say, I want to use this Docker file that is located there, and it's called in that way. But if not, you just put it in the default location, and then
Alex is the guy that wrote all this, so he knows it in great detail. I'm more a user of this stuff. I actually use it in production. It's very mature, works very, very well, and it's a much simpler way of creating all those integration tests. You know, if you do have multiple services, and obviously with microservice architecture, we're going to be having multiple services, I would suggest going this path and only use the end-to-end test and all the Arquillian deployment features if you don't have access to a Docker environment. The cube example that we have, that's going to be...
Well, you can run...
I just wanted the Maven console. Yeah, I just run the Maven console build.
Yeah, this is an example of Arquillian persistence extension and Arquillian Cube. So you have here both testing frameworks integrated. No, but run directly because it will run all the suite of all the...
Sorry.
Yeah,
you do.
Yeah, well, yeah. I mean that it will be easy. Just here, what you can see is that I'm defining the Redis container, and then I need to define where this server needs to. I mean that where Arquillian persistence extensions need to populate data, and in this case, I'm using this. Arquillian Cube creates some default system properties called arc.cube.docker. The ID of the container, and the same for the port. And then here I'm using the declarative, and what I'm saying is like, before executing this test, I start up the Redis container, populate with books.json. That books.json is...
This is more going back to the persistence test I wanted to do there.
This books.json is this file, which is just... In Redis, this is a hash map where you say the key is the habit, and then the values are fields like the title, the habit, a number of pages to 930. And then what I'm doing here is just have my book service, which will connect to this Docker container, find the habit, and then you assert that the habit is already there. So if I run this, okay, now I need to pull, well, meanwhile it pulls the Redis image. Let me show you the other example, which is the...
No, let's just do the OpenShift.
Yeah, OpenShift is for deployment, yeah.
Oh, okay. Yeah, sorry.
And then, for example, here, this is another example, which we are mixing two of the supported technologies. Because when you're running with Docker, you have a problem that Docker are volatile. When you stop it, all the data that is there, it's removed. So you need to start a container, populate the schema, in case of SQL databases, populate your data, and then run the test. And this is what we are doing here. I'm using Flyway. Flyway is a tool for populating all the populating the schema of the database. So what's going to happen in this test is like, I'm going to start PostgreSQL database. When this PostgreSQL database is started, I'm going to populate it with Flyway a schema, which is in DB migrations. And in this case, DB migrations is, it contains a SQL database which creates the schema Hollywood and create the table Hollywood.film with the title and the release text. When this schema is populated, then I'm going to populate with some data because I need some data there. So in this case, I'm using the YAML, which is films, the title trolls, and the release date. And when all these things has happened, then I can query the database and validate that everything is in place. And finally, of course, I can do some kind of flyway.clean, which basically drop everything, so I don't need to do dbunit.clean and then flyway clean. With clean, everything it's removed. And if now see that this is the previous test, it's green, it's downloaded already and run. If you want, I can run this test. And notice, yeah, this is starting the PostgreSQL database, creating the schema, populating with some data, then run the test, and then clean everything. And it runs pretty fast, I guess. You've seen that it was fast. Well, now let's see something that it's more focused on microservices architecture, which are, we have tens of services interconnected between them. And one of the things that microservices architectures makes you, or force you, let's say, is like each of the service must be deployable independently. So you can have 5 services, and they said, okay, I want to deploy a new version of service C. And one of the problems is that how you can ensure that when you deploy service C, service A will continue be able to consume data from this new service, because you are deploying independently. You are not saying I'm deploying A and C. You're deploying C, and all the structure will reach this. The truth is that sometimes it should be easy, but it's not. I mean, in my experience with microservices, before using this, we faced a lot of problems of interaction of, I've deployed new service C and then service A start failing. And why is service A it's failing if I have not touched anything from service A? And it's like because service B, it's changed how he's producing data. And this is exactly what we are going to see now. The example, I'm using Postman, I mean that I'm not using any browser. Then we have a consumer with version 1, which is deployed with Vertex. And then I have the producer. The consumer is the service that consumes data from another service, and the provider is the service that exposes data to another service. So what's happened if, I mean that this is running in OpenShift in this case, so in Postman I do get billions grew, and then I go to the producer and say, okay, give me all the information about grew, all the crimes. It returns a JSON file, which is name, moon, billion, grew, and wiki, the Wikipedia where of the crime, which is stealing the moon. And finally, the consumer, which is the billions database, is just add or append its own data. So you have the name, it's grew, the area of influence is the world, and then it appends everything that comes from the provider. And that's great. The problem is what's happening if I update producer to v1.1 and it remove the wiki. Then it might work or not, depending on consumer. If consumer is not implemented taking care that one field can be removed, then it will fail. And this is exactly what contract tests are. Contract contract at the end, it's an agreement between consumers and producers on how the API should look like. So, I mean, that it's like in real life, contract is something that two parties agrees on that need to be followed. And contract test at the very end provides a mechanism to explicitly verify that a component meets the contract. And when I said the component, I mean the consumer and the provider. So with the contract test, you verify that the consumer meets the contract that have an agreement, and the provider also meets the contract that has agreed it with the consumer. Let's see how it works from the consumer side. In the consumer side, you need to generate a contract using a test. And you have the consumer test, which is the responsible of generating the contract. Then, instead of using the real service B, you're using a stub server. This is done because you don't want to boot up the real service all the time, because as we said with service virtualization, this ends up with an end-to-end test. Then what we need to use here is the client class. This is the gateway class. Use it to communicate with the provider. So it's really easy. The only thing that you need to start doing is just, I'm the gateway. I know that I want to get all the clients of GRU, so I'm going to do this call to stub server. And a stub server will return the JSON that has in its own expectations. Finally, the consumer test will generate a contract, and this is the contract, the real contract that both the real provider and the real consumer needs to follow. Notice that this is really, I would say, it's almost the same as service virtualization, because you're using a stub server which has some expectations, and then you generate a contract. And then this contract must be somehow moved to a repository so it can be shared with the provider. Because this is the consumer side, you generate the contract, and this contract must be consumed by provider to validate that everything is fine. So what's happening in the provider side? Basically, we have a test class which replaces the request against the real service, a real provider, right? So what's happening is it reads the contract and starts to replay all the request and response that were stored inside that contract. And this generates a file. Then this file is compared with the contract file. And if this real file of the provider meets the expectations of the contract, everything is green, then it means that I can deploy provider safely because my current consumer will be able to consume its own data. If it fails, it warns me to stop deploying this service. And there are several, or actually there are like two contract test frameworks. One is Pact and the other one is a Spring Cloud contracts. Spring Cloud contracts works pretty well with the Spring and all Java projects, but that's all. In case of Pact is a foundation, and it means that there is an external party that generates a specification. And this means that it integrates with several languages. All the JVM languages, Scala, Groovy, Java, of course, Ruby, Python, Go, the .NET, Swift, and JS. So it means that if you are using a polyglot approach on your microservices architecture, you use the same tool for all the contract tests. And finally, it has something called Pact Broker, which is like a hub where you can store contracts and consume from there. So you don't need to store them on, for example, on a shared folder or on a Git repo or whatever. You can use this hub. And finally, it integrates with Arquillian, which is called Arquillian algorithm. So it means that you can use all the things that we have explained about Arquillian in the component testing for persistence for Kube, but also for Pact. In the consumer side, I'm going to just go to the demo because we're going to see this. It's faster. Notice that now I'm going to, I know that you're not watching anything. I'm starting Minishift. I have my beeline crimes application deployed on OpenShift. And if I can open the project, which is the beelines, let's just start with this is the this is the test, right? No. Wait, then I think that this is the test. I need to run with Arquillian, and then I put here the stub server. This is the provider server, which is the crimes. And what I need to do is just define in the consumer side, remember that I said, you need to define the expectations of the contract. So you annotate that you want to define a contract for the provider crimes and for the consumer billings. Because at the very end, you can have the same consumer consume data from several providers. So you need to specify which provider and which consumer you're defining. Then you define the contract. And this, it's the contract and the expectation, which is basically said, upon receiving GRU billion to get all crimes, path slash crimes slash GRU, method get will respond with the status 200 and the body response this response. And this is really important because in this case, what I'm just defining how my API looks like. Also notice that Pack will generate a documentation with this. So you will have a documentation of your API as well. So everything that is not defined in the contract, then it's like a free field. So you need to be really curious on defining this. And then you just need to run your test as usually, saying that you want to generate a contract for the crimes provider. If I run now, takes this and now, okay. And now notice that it says green. And it said, okay, for your incoming, your assertions is okay. And notice that here I'm asserting that the name of the crimes are and the wiki are Moon and the wiki Moon, and the Times Square Jumbotron is the Times Square Jumbotron. So I'm asserting that the expectations that I've recorded here are correctly met. And if you check on build packs, you see here a JSON, and this JSON is the real contract. This is the contract. This is something that this JSON will be used by Pack to generate the documentation for you. And notice that it says for the provider crimes and the consumer billings, there is these interactions and must follow this. This is the thing that is going to be used on the provider side. What's happening in the provider side? It's the crime service. I need to do something different, which is basically says, I want to use Arquillian, I'm crimes, and I need to check where are my contracts stored, because contracts are generated on the consumer side. In this case, I'm using the contracts folder, which is like a disk. This is good for demos, but not for production. In production, probably you will use Pack Broker or even, for example, Git server or whatever. And then the only thing that I do is just say, I define target. Target is a class provided by Arquillian and says, assert that this target with the URL of the crime service, because this is the provider, satisfies the contract. So what's going to happen is like read the contract, so it's reading read this file and said, okay, I need to go to /crimes/gru. So it's going to connect to this URL. And then in this URL, we said, I'm expecting the response, and then it will assert if the response is this one. If the response is this one, then you can deploy providers safely. If not, then you're going to break something. And then if I run the crimes, again, I mean that now it's starting the Vertex service. And then when it's started, it will start replaying all the requests and response. You can see that now here it's saying, I'm verifying the pact between billines and crimes. Group beeline to get all crimes. Return the response which has a status code 200 and says, okay, yes, I did this interaction, I need to return it, and has a matching body and says, yes, it has a matching body. So your test is green. What's happened, for example, is if I go to crimes, wait, well, I can go directly to crime, and I said, look, I don't want to add wiki. Now said, I'm going to remove wiki from this exposure. So wiki now is not serialized to the output. If I run again the project, you have a failure. And says, basically, if you check here, well, like here is all the difference and says, oh, wait, here. Has a status code 200, it's okay, but matching bodies failed because I expecting the wiki field, but there is no wiki field. So before deploying your provider, you get the failure, not when you have deployed it to production, and then consumer start failing because of this missing field. Fix it. I think that you only need to move the screen, right?
Yeah, this needs to go over here.
Then it's on the other. It didn't. Yeah, it's.
Oh, we didn't go down yet.
Oh.
Okay, we're skipping questions, I guess, on that.
No.
Yeah, deployment tests. Yeah, sorry, before I got kind of confused with this one. I was supposed to be doing this one and skipped it on my slides. Yeah, Arquillian Cube, back to Arquillian Cube and deployment tests. Obviously, when we're generating all our applications, we need to make sure that they deploy perfectly well in the containers that we're intending to deploy them on. And this is where we kind of sew in with Fabricate. So Fabricate is the interface, let's say, to OpenShift and Kubernetes. So if I have a Kubernetes cluster or an OpenShift cluster, I'm going to be using Fabricate to make the deployment, and Arquillian is our enabler as such.
Yeah, basically what Fabricate does is usually when when you start in the microservices world, you said, okay, I'm going to deploy this to Kubernetes or OpenShift, and you start generating a lot of, Kubernetes.yaml files, each one for each of the service. And you end up by having a lot of copy paste between all the services, because at the end, you always use more or less the same configuration for all the services. So what does Fabricate it says to you, look, don't spend time on writing these Kubernetes YAML files because I'm going to do it for you, because I know what are the best practices, so I can provide you one opinionated file for you, so you don't need to need to create it again and again for all your services. Well, because now you are.
Oh, sure. Yeah, so this is basically the deployment test that we're going to be running, and this is with a new runner, so the Arquillian conditional runner class. And what we're saying is we require Kubernetes or OpenShift for this test. If that isn't fulfilled, if it doesn't detect the requirements on the class path or as a service, running service, then the test will fail before it begins. And if it doesn't, it's going to actually return us the URL required to access the Kubernetes Hello World deployment. So that's just going to be a node deployment of Kubernetes Hello World. And Kube is going to enable that for us. It's basically going to ensure that the deployment is deployed as a node in a particular namespace on our cluster environment. And then we can test against it. So we're just going to go back to a standard unit test that makes a physical HTTP connection to the service running in the container. How do I get this screen to open?
No, well.
So that's the project, or the code for the project, and the project just consists of this simple command line. So it's going to be running in Maven, and just running this will actually deploy.
Yeah, this test is really a big test. I remember in the past when you created the WAR file, and then you take this WAR file and put it in the application server, and you boot up the application service, and you check if it runs or not. It just, like a check that the WAR file was thoroughly created, all your configuration files were in place, and if the services boot, then you said, okay, everything is fine, then we can continue. This is the same, but for Kubernetes and OpenShift. And in this case, notice that now it's Fabric. Oh yeah, I know what's happening.
Is that the same on mine?
No, it's but.
So the first test that was run, that was a Spring Boot test. So that was testing the Spring Boot test works and it can create the deployment. And then the second test, we actually send the deployment to the container.
Yeah, it was a problem with the security on OpenShift.
Oh, let's see login.
Yeah, you need to log it before because you need to provide the credentials to get into the Kubernetes cluster. But yeah, this is just a Spring Boot test that runs locally to check that locally you can start these microservices. It takes some time. And then after that, Fabricate will generate all your OpenShift Kubernetes stuff automatically for you. I mean that if you check the project, you will see that there is no Kubernetes stuff anywhere because we delegate to Fabricate. Of course, it's opinionated, but it's also customizable, so you can change everything. Notice that here you see an app that's saying using Docker image. Well, it doesn't matter this. And then they said adding a default service, a Spring Boot HTTP with port 8080 because we integrate with Vertex, Spring Boot, and Wildfly Swarm. So we detect the configuration of Spring Boot in this case and said, okay, Spring Boot is running on 8080, so I'm going to expose this port because this is what I want. And it creates a service and so on and so far. And yeah, the problem is it takes a bit of time because then, yeah, no, but it's running. It needs to create the Docker image. I mean that it needs to create the jar file, create the Docker image, build the Docker image, put the jar, put create the Kubernetes file, put this Docker image inside the Docker registry of the Kubernetes cluster, then deploy or send the resources file to the cluster, deploy everything, and yeah, and after now I think that it's deployed. Normally it takes like 9 to 10 seconds to deploy to OpenShift. And then in the test, what we have is like checking that the URL, notice that it's run and there is no failures, success. And then it checks using the URL with rest assured, we check if there is something deployed there. Even if it's something deployed there, we said, okay, we know that we are able to take our application, move it to Kubernetes cluster, and it's going to start. And notice that if you check deleting project, you see here, there, they said deleting project, itest44e, just in the very end of the build, right? Because in this case, Arquillian Cube, by default, what it does is just create a random namespace. So you are not touching your production environment. You are in the same cluster of production environment, but not in the same namespace. So it creates a random namespace, deploys everything there, run this test, and then removes this namespace. Of course, if you want, you can just point to the production environment. You can do it as well. But yeah, by default, goes create this random stuff.
Again, these kind of tests, they definitely go into something like Jenkins. They need to go into your deployment pipeline. You wouldn't run this as a developer on your own box. This will be running on a Jenkins deployment pipeline.
Yeah, and this is the test. In this case, I'm using OK HTTP, and then you get the request, and notice that you are putting the URL of the cluster, or is the URL to access to this service inside the cluster.
So we're not actually testing the application itself. We're just testing that we can deploy the application, and the application is reachable on the endpoint.
Yeah. This is demo, and then yeah.
Back to Alex.
Then with microservices, something that is really important is continuous delivery, going really fast to deliver something. You need to pass from delivering from once per week to several times per day. And this has a problem, and is that you need to speed up your test. If you run all your suite all the time, you're not going to be able to run several times per day. Because if you want to run all the tests or everything, it would take a lot of time. So we created one tool called Smart Testing. This is, again, a project on the Arquillian umbrella, which basically is like, usually, when you when you modify one class, this class is tested in 3 or 4 tests, directly or indirectly. But it's there where it's used, not all the tests. So when you want to run your test, maybe you have modified this class, and this class is tested in this test. And that's all. From the whole suite, you only touch directly or indirectly these classes in this test. So why you need to run all the tests if you know that the modification you have done is you just need to run the green ones, because the other ones, you know that it has nothing to deal with this production change. And we have a smart testing Maven extension, which basically, to install it, you just need to run call. Well, you can, I mean, in the documentation page, you can see everything, but basically you just do this call SSL, this URL, and pipe bash on the root of your project, and you will have smart testing installed. And then you can do something like Maven clean test, -d smart testing, new change it. And this means that I'm unaffected, sorry. So in this thing you're saying, I only want to run tests that it has been added in my current commit, or it has been changed in current commit, or they are affected by a change on a production class. So it's like saying, I'm going to filter from all my test suite to just the new test, the changed test, and the ones that have that test some change on the production classes. This has changed in recent versions. You can even create a YAML file, a configuration YAML file, so you don't need to specify it as a system property. And finally, if you don't want to if you want, or you still want to run all the suite, but order it, you have the ordering method. This ordering method, what it does is like saying, okay, I'm going to order all my test plan execution. So the first tests that I'm going to run are the new ones, then the changed ones, then the affected ones, and then the rest of the tests. Then again, you're running all the tests, of course, so you still have problems for speeding up your build pipeline, but yeah, you can order it. And again, this is one way to speed up your pipeline. But there are others. Sometimes you just deploy, that you have your service, you run all the tests, all of them passes, your contract test passes, you go to production and you say, yeah, we are in production. But yeah, you break the environment. And this happens because production is production, and it's never easy to deploy in production. There is a DNS, there is different kind of networks. Maybe there is some users that comes from Kenya that have some different header in the browser that makes everything blows, and this happens. So what you need to do is test on production. And there are several techniques. The first one is the blue-green deployments. The blue-green deployments basically is like, I have this, I have my service, and I have my users that connects to the blue service. So what I do is like, I create my build in the development side, then maybe you go to QA and you verify that everything goes as expected. Then you move to staging. Maybe your product manager says, yes, this is what we want. And then we move to the cluster, but not directly on the, on the production cluster, but not on the green yet. You put it in the cluster and then you say, okay, I'm going to start doing some kind of a smoke testing to validate that I'm not going to break anything. When you are done with this, you move to green environment and you change the route. So then the users, instead of using the blue one, it starts using the green one. And this is the way of how you can test on production. So you just test on the same cluster, then you move to green, and then it's really important to monitor your application, because this change, you can still break something. And then you said, okay, I'm going to monitor, and if there is any failure, then what I need to do is just switch back really fast to the blue, because you are not undeploying blue, you're just changing the route. So you change the route to green. If everything is fine, okay. If you see in your monitor that there is a lot of failures, then just come back to blue really quickly. In case of failures, change to blue. But there are other techniques. The one is canary release. And do you know why it's called canary release? Anyone knows or don't know? Who don't know why it's called canary release? Okay, it's called canary release because in the past, in the coal mines, there was some dangerous gases, right, toxic gases that humans die after 2 minutes of breathing it, okay? And the canary just dies after 5 seconds. So what they said is that, okay, I'm going to with this canary, I will put it on the mine, and if in 5 seconds I see that the canary died, then I need to run out really quickly.
So it's all about killing canaries.
This is why it's called canary release, because you're doing something exactly the same. If we've got the green service with all the people there, and then you have one change. This change goes to QA, staging, and then you put this change on your blue environment or in your current environment, right? But only a small part of the users are able to connect to this change. Let's say, for example, 5% of the users can reach this new functionality. And you start monitoring. If there is no failure, everything works as expected, you increase to 10%. If there is no more failures, to 50%, 80%, until you get all the users with the new feature. So instead of just saying as like blue-green that you deploy everything at once so all the users see the changes, you do it this step by step. And finally, there is dark launches. And basically, dark launches is like more or less the same, but the change is used by internal users. So you've got, this is really it's used by, for example, Facebook, where their own employees uses Facebook internally. So when you connect from your internal network, from your workstation, you start testing the new features. Then someone monitorizes all these changes, and when they say, yeah, we are good, then they make this public to all the users. It's also happened this with Facebook Messenger. They did something similar, which they create some kind of bot on all your pages without knowing. So they have Facebook Messenger implemented, but you didn't know it. And they send you the JavaScript code, and they start sending dummy message to their systems. So when you were in Facebook, they were doing these kind of things. When they saw that everything was working fine, they just enabled the JavaScript, they changed the flag on the JavaScript, and then you see, oh, look, there is Facebook Messenger, but you have it there for maybe 2 weeks. This is what I do. And if you want to see a really quick demo about this.
So that fancy notebook you were bidding on eBay that you didn't get could have just been them swapping the services over.
So I'm going to connect to, let me check if because I don't remember now the IP. This one. Well, in fact,
Do OC dashboard.
maybe the DP has changed. Let me. Okay. Okay, this is my two services. I have blue service and green service. And this is the URL to access to this service. So if I go here and I do call this one, I got hello from blue. And now I just have hello from blue all the time because I just wrote to blue service. What happened is I said, okay, now I've deployed green. I already deployed and I want to change to green. I just need to do something really easy that is like OC set root backends, blue, 0, green, 100%. So with just this simple call, I'm just going to green. Now I have green all the time. So if it now said, oh, look, I break something, I can go here, I can put here a 0 and then 100. And then I have blue again. And if I said, okay, but now I want to just put 50% of users to blue and 15 to green, then I'm gonna start doing call. Now it's blue, now it's blue, now it's green, now it's blue, now it's blue, now it's green. So it's really easy to implement with OpenShift this blue-green canary release. So Andy, you can finish.
Yeah, I think that's our summary, basically. Lessons learned. We're taking something that we know already, which is unit testing and component testing, and we're just taking everything that we've applied to monolith applications, and we're adding just a few bells and whistles, a few different kind of tests to enable our microservices. So we're not getting rid of anything, we're just adding stuff. We're not having to learn new frameworks as such. We're staying within JUnit. Obviously, if you've never touched Arquillian before, then you're going to need to read documentation about Arquillian. But it's just building upon something that you know already. So that process can be very, very quick. Anything else you want to add?
No, you can.
So we've gone through and we've covered all our tests. And basically what I've just said, we're appending stuff to our environment and adding a few new scenarios. So we're going to be doing more integration testing with services running in the background, and we're going to be using Arquillian Cube to run those services for us. And we still continue to test as a team. So rather than just developers now, we're involving everybody. So it's the classic DevOps scenario where everything is now part of the enterprise, and we're not going to just sit in a dark room and not talk to anybody anymore. We need to talk to everybody, and everyone needs to be involved in that process, especially because we're going to be testing deployments. Secure steps.
Yeah.
So, each stage. So don't go off and try and do everything at the same time. Build progressively. At each stage, you're going to be physically testing that what you've done works within your environment, and you're going to be involving the whole team in that environment. We want to automate everything. So everything we've presented today can be involved in some kind of pipeline. So we have the classic Jenkins pipeline. Everyone knows and understands Jenkins very, very well. Because we're not stepping outside of that box of how we run things, we're staying within usually a Maven environment or a known environment that we can deploy on Jenkins. It's very, very easy to automate everything we've done today. I have no idea what that's saying, Alex. Change is the essential process of all existence. I can read it for you, but yeah, obviously things change. The future is never fixed. We haven't gone too far outside of the box on what microservices are, so we presented what we thought microservice was in its basic elements. Things will change, but the things we've laid out and the things we've presented today and the stuff we actually have in the book are going to be stable for a very, very long time. It's a principle more than anything else, but be prepared, obviously, to update things and ready for change. We provided links. This has all been video. This is live, so we can go back and laugh at each other later, and hopefully you can laugh with us too. So with us, not at us. We'll also be publishing the slides. The video will be uploaded to YouTube, and hopefully you've enjoyed the talk and the things we presented today. Thank you, Alex. We have exactly 2 minutes and 30 seconds for questions. I would suggest if you do have questions, it's a big subject. There's a lot of stuff in there, a lot of information to take in. Go back, get the information, come back and talk to us. Tweet to us, we'll get back to you, and we can start some private conversations. You'll find me on the Apache Tommy project. So if you join the user list, dev list of Apache Tommy, I can answer all the questions there. Alex, is it?
No, from wherever.
From home, yeah.
From home.
Thanks very much for your time, people.
Thank you.
Enjoy Devoxx.